Unit 5 in your syllabus is nothing but linear programming problem, which consists of formulation of LPP and solution of LPP. Let us see what is linear programming problem is. This is also called simply LPP. This consists of representing the given situation in mathematical form. So an LPP consists of formulation of LPP and solving the LPP. After the few steps you will understand the meaning of these two: formulation of LPP and solution of LPP. Now let us see what does an LPP consists of. An LPP consists of three parts, which are called the objective function, constraints, and non-negative restriction. These are the three parts of any LPP. So if you are going to write a given problem as LPP, it should have all these three parts called objective function, constraints, and non-negative restriction. So these LPPs are commonly known as comes under OR, which are also called the optimization techniques. Optimization techniques means you are going to maximize the given situation, or you are going to minimize the given situation or the problem using available resources. So LPP is also called constrained optimization. Constrained optimization means using available resources, you are going to either maximize the profit or you are going to minimize the time or the cost of the given situation. So let us see what does an objective function represents, what is a constraint representation, what does a non-negative restriction represents. So let us take a simple problem that let us see that any industry, let us take an industry which produces different types of articles. Say it produces suitings and shirtings. Okay, and to produce these two types of products, each either suitings or shirtings should undergo 3 phases of production. The 3 phases to get the final output of a particular suit, it should undergo these 3 phases. Similarly, to get a particular output or the product of the shirt, it should undergo these 3 phases. So we say that the products of these industry are 2, and available resource, these are the 3 machinery available for getting for producing the corresponding output. So we call these are the outputs of the given, or these are the outputs of the given situation, and these are the available resources we have to produce these outputs. And you know that we never have a case where there are unlimited resources. If you take this as a mission 1, it will have either daily or weekly, it will have limited hours of work. Similarly, it will have a limited hours of work. Similarly, the third mission will have limitations on its working hours. So let us say that the profit on each shirt is, let us say that it is 40 rupees, and profit on each shirtings is nothing but, let us say it is as 30 rupees. So this is the problem given to an industry is there, which is producing 2 types of products called suitings and shirtings. To get the final output of each of these products, they should undergo each of these missions. And also it is given that you are given a limited work hours on each of these missions, and also given the profit on each item, each product is 40 rupees and 30 rupees here. Now the question is here, how many of these suitings and shirtings to be produced so as to maximize the profit? As I said you that these LPP are optimization techniques. Either you'll face a problem of maximization or minimization. All of you well know that if it is a problem of profit, always you should go for maximization. it is a problem of cost, you should go for minimization. If this is the question given to you, this is the situation, and how many each of these suitings and shirtings should be produced so as to maximize their total profit. For that, you need to solve such a problems. First of all, you should formulate the given problem as LPP. Means you need to frame each of the parts called, you should frame the objective function for this, you should frame constraint for this, you should frame the non-negative restriction for this. So the given word problem simply, or in your long, the given situation or word problem should be first of all should be formulated as LPP, which consists of these three parts. After formulating this, you are going to find the solution. What do you mean by solution? How many you are questioning, means how many after formulating the answer. So 400 suitings should be produced, 300 shirtings should be produced, and you should get a quantitative numbers for each of these products, which gives the solution of LPP. So whenever a problem is given, or a situation or a word problem, anything is given, you should read the given problem and you should formulate this as an LPP containing these three, and you should go for the solution of the LPP. Let us now go for how to write an objective function for the given problem, how to write a constraint for the given problem, how to mention the non-negative restriction. As we are calling that this is producing two types of products called suitings and shirtings. So how many products we have? We have two products. So as we are calling this as a linear programming problem, you are going to mention variables in that, which are called as decision variables. The decision, how many we should produce, so how many items we should produce, the decision is dependent on these variables, which we call here as decision variables. Generally, the decision variables, the number of decision variables is always equal to the number of outputs or the products in the given problem. See, in the present one, how many products are there relating to this industry? We have suitings and shirtings. So entire these three parts are going to dependent upon the two decision variables, which are equivalent to the two outputs. For suppose if the given situation has, if it is producing four types of items like pens, pencils and erasers and boxes, there we are going to have four decision variables, means number of products are going to represent the number of decision variables in the given problem. In this present one, we are going to have two decision variables. After identifying the decision variables, you should write the objective function. I said that these are the three parts of LPP: objective function, constraints and non-negative restriction. Before writing mathematically, let us see that what does this objective function refers to. This name itself tells that objective. As I said you that LPP are nothing but optimization techniques. What do you mean by optimization? Either to minimize or maximize. That is, in the objective function, you should clearly specify whether your problem is a maximization case or minimization case. If it is a problem on profit, you are going to start the objective function as max. If it is a problem on cost, you are going to write that min is equal to. So in the objective function, you are going to write whether the given problem is going to be a maximization type or minimization type. Function, let us see, by taking a numerical example, I will tell you how to formulate. First, in the objective function, you are going to specify the objective of the given LPP, which is nothing but maximization or minimization. These constraints are also called the limitations. As I said you that no industry cannot produce any output without any resources. Obviously, those resources will have some limitations on the work hours or the availability of the resources. Means you should specify the limitations of the available resources. So in the previous one, I said you that it should undergo three missions called M1, M2, M3. It cannot work for 10 hours per day. It cannot work for 8 hours. It cannot work for more than 14 hours. Means in the second part called constraints, you are going to establish limitations of the resources, which may be sometimes less. You may get maybe this may consist of sometimes the symbols called less than or greater than or sometimes equal to. Whenever we use the word called at least, we are going to use the symbol called greater than. Whenever we are going to use at most, we are going to use the symbol called less than. If it is given exactly, we are going to use the symbol equal to. Means under constraints, you are going to express given availability or the limitations of the resources in the form of equations or inequations, and if depending upon the availability, sometimes maybe it cannot work for more than 8 hours, so you are going to write less than or equal to 8. It at least the available resources is nothing but at least 50 kg. You are going to write that as greater than or equal to 50. Means you are going to express the availability of the resources in the form of less than, greater than or equal to, greater than or equal to. Third one is nothing but very simple one, non-negative restriction. Name itself tells that no items, you know that all the items, you are saying that x1 and x2 are the decision variables. These are the number of shirtings to be produced. These are nothing but number of suitings to be produced. I think after formulating, I think no answer you should get in negatives. I think we cannot produce negative number of items. Either you may get 0 items to be produced or 4 or 10. You cannot produce -4 suitings, -4 shirtings. That is, in non-negative restriction, we are going to specify that all the variables, all the decision variables are under study are non-negative in nature. That is LPP, as I said you that you need to formulate the LPP, then you should go for solving an LPP. So before solving the LPP, you should formulate it. Formulating again involves framing the objective function, constraints and non-negative restriction. Objective function means here you are going to specify the objective of the given situation. In the constraints, you are going to establish the availability of the resources in the form of inequations. Under non-negative restriction, you are going to specify the nature of the variables, that the variables used in this LPP are always non-negative in restriction. These two together called LPP. So this is about the introduction of the LPP. Let us see in the next video how to frame the formulation of the LPP by taking a numerical example. Okay.